Hello viewers, today I will speak about the batteries, or how to get the stored energy out of the battery, or how to return it to the battery if we are using rechargeable batteries. It's not so simple how one would think, but it's not even too complicated. Now you will see. So this is a standard Duracell battery with, I don't know, 2400 milliamp hours. And here we have example of that one light emitting diode is connected to it. So what happens? So it's easy. When we close the circuit, we allow the current to flow from one to the other side of the battery, from the anode to the cathode. It has two poles. So when the circuit is closed and we have the load in between, like the light, it will actually power it. So it works fine. So what happens in the battery? This chemical reaction which actually enables us that we get the energy out of it. So here you can see the following example. So to be able to get the electrical energy out of the battery, we need the two type of chemical reactions. One is called oxidation and one is called reduction. Oxidation means that from one side of the battery, from let's say from the metal part of the battery, it reduces the electrons, so it separates or it loses electrons, and these electrons are transmitted to the other side of the battery, so the positive pole, where it collects these same electrons. So if I go in detail, I have to explain this image because it's a little bit confusing, but you will now understand when I do it more in detail. So, oxidation and reduction. So, reaction in which some molecule, atom or ion loses electrons, so these electrons over here, it calls itself oxidation. Yeah? And this molecule, atom or ion, which oxidizes, this one oxidizes, loses electrons, we are calling reduction agent. So it's a little bit confusing because we have the oxidation and reduction on the same side. But this is the reduction agents, and then in the process of oxidation it leaves the electrons or loses electrons. And on the other pole of the battery we have the other reaction. So reaction in which some molecule, atom or ion accepts the electrons, so these electrons from here to here, these electrons, so we call it reduction. And these molecules, yeah, atoms or ions which are reducing or accepting electrons, we are calling oxidation agents. So we have, this is a little bit confusing, but this is the oxidation agent, which consists of the atoms which are accepting electrons by means of reduction, and we have the reduction agent which releases electrons by means of oxidation process. And this is it. This flow of energy or electrons, this flow of electrons, free electrons, from the positive to the negative side of the battery, this is actually enables the current to flow through the battery. So if we have here the rechargeable battery, then we have better solution, because we can return those electrons from the positive pole of the battery to the negative pole when we connect, instead of the light, when we connect the DC source or other battery. So we will then reverse the reaction, and we will return these electrons on the same place they were, not on the same place, but in the same way on the atoms which have released them in the first place. And this is it. If I go into one datasheet of the battery, so this is the datasheet of the Duracell rechargeable battery, we can see following things. So this is the nickel metal hydride battery. So I think that oxidation it happens in the nickel, and the metal hydrides, it's the part where the electrons are accepted, but I am not sure of that. It should be checked in some more detail documentation. So Of course, in datasheet we have the charts which are showing us how fast this battery can charge and discharge, or how much time can we use it in some constant current. So this is not this datasheet, but I'll show you another one on the fast charge, and this is the time in hours, how much can be used if it's, let's say, 3 times the capacity, yeah? Or one capacity is for 1 hour. So if we use the full capacity, what can give, it can be used for 1 hour. And if I go to the alkaline datasheet, battery for the alkaline batteries, also Duracell, we can see here that it has better charts which explain in which current, if we spend some current, how much hours it will work. So 50 milliamperes, it's, let's say, this is how much spend the average light emitting diode. So it will, if you see the chart, light emitting diode can work almost 60 hours on this single battery. Yeah. And if we use some smaller consumer, like maybe a watch, yeah, which uses 5 milliamps, it says that it's about 600-700 hours. So it's impressive. Yeah, I must say it's impressive. And on the constant current which can be used from the battery. And we can compare this battery. It has, I think this is the same 2450 milliamp hours, or 1500, but I'm not sure. I think this is the model name. And let's say we can compare it to the Sony Xperia. This is my mobile phone. It has the battery which has 3.8 volts, but normal one I showed before, it's 1.2 volts. And this one from Sony has 3200 milliamp hours, and it can in total give 12.2 watt hours of the power. So we could, in theory, connect 12.2 watt, let's say, light source, and it will light for 1 hour with this battery. This is it. This is it. This is all what I can say about batteries. So it's a chemical reaction in which the free electrons are transmitted from the one side of the battery to the other side of the battery. If you think in other terms, actually the energy is not lost. It is saved in this column, the plus pole of the battery. If we are using standard battery, it's alkaline. And yeah, but if you're using rechargeable batteries, this can be restored again in the primary metal, which actually releases the electrons. So this is it. This is all you need to know about the batteries. It's the chemical reactions happening, and from these chemical reactions we get electrical current. So thanks for watching. Until next video, bye bye.